Suzanne has drawn some great camels, and I've checked them online, and sure enough, that is the way they are shaped. So what we need to do, and one of the things I want to point out is notice how gradual it is. It's like a gooseneck, you know, instead of the elbow is more like a V, all right? But what I'm picturing is a universal joint down here that we've got one actuator moving it this way and another actuator allowing it to move this way, okay, on the universal joint.
Wow.
So I talked to Steve about it, you know, put together a small price list. Then I realized that, the universal joints which we use and love, at least I love, one of the reasons why we love them is they got the flanges on them and they got hard limits. You know, if something broke on the motion platform, it wouldn't just fall over. It would only go to about 20 degrees and stop. It's like, oh, that's a problem. We need to be able to take it further. So that's, 20 degrees each way, so you got a 40-degree swing. Now if you bolt two of those back to back, now what happens is you've got less of a V and more of a U, and now you've got more motion. Okay?
Nice.
So we just doubled the price of the universal joint. One was $60, universal joint and the two flanges. So now we're up to 120, but we solved two problems. And we still have the strength. That's the other thing that's absolutely critical to what we're trying to do, is that, here you've got a head up here which may weigh 10 pounds. You've got a 3 or 4 foot neck, and it's going to be stretching out. So there's going to be a fair amount of, leverage and tension against it. And we don't want it sitting there swaying when, a camel blinks and all of a sudden his head sways. It's like, can't have that. So the universal joint, in my mind, is the way to go. We're able to, to mount both sides of that with, tubular or square or whatever, steel stock, aluminum stock, whatever we choose, and have the frame up the neck and the frame, down the neck from the body, be solid. That also gives us, a way to route the wires. And you saw some emails to John talking about we need to embed the electronics. We need to make sure that one set of electronics isn't interfering with another, as we learned on the motion platform, etc. So we've got a good way to go there, but I think that we want to do some of the experimentation here. Okay. I think that in a month and a half we could have a decent shoulder of the animal, down to the neck, back, down to the base of the neck, and then back up and have that solid. So the next logical step after that, now we're going to put a head on it. Why not learn what we got to learn?
Right.
Okay? So we haven't talked about that yet. We haven't priced that yet, but that is obviously the next logical thing, because then we can run the wires and make sure all that works. And just so you know, it'll be the USB cables that go all the way up to the head, and the power cables that go all the way up to the head.
Yeah.
And the processing is done here, and then the interference would only be amongst those kinds of things.
Yeah.
As it goes by the actuators, power is here, and the universal joint, USB cable to a helper tooth saber tooth combination. So we've got those kinds of things figured out.
Should be fine.
Right. It fits together well. Now the another part of the discussion that comes in here is Dave is suggesting, and rightfully so, these window motors. So, they're 20, 30, 40 bucks instead of an actuator, which including the pots is going to be about 125. When you figure two actuators, 250 bucks compared to two of these motors, 35 bucks each, 70 bucks, you start saying, whoa, Tom, can't you save some money here? And the answer is yes, but, in my opinion, we all do what we know first. If you don't know anything, you go out and learn something. So that's what we did with the actuators. But now that I know that, that's where I'm comfortable. John obviously is comfortable with the servos and does a great job with those. Dave has experience with the window motors, but one of the things that's going to end up happening is it's not just moving it, there's, turning the motor on and off. It's how do you mechanically attach it. So I think Dave can help me with insight on that. But then the next thing is, how do you electronically control that? We can do that with a saber tooth, but how do you get the feedback? Now it doesn't have internal potentiometers. So we either have to install an encoder, or we put an accelerometer up there, which will then tell us all 3 motions where it's at. Don't know how to do that yet, but we can learn that. So, but the problem again gets to be, it's not just getting the feedback, now you have to process it. Okay, so which electronics is going to do that? Because we don't want that coming back to the central PC, because we're going to overwhelm it when you've got all these motors to run. Okay, so where am I at with the 2 things that I wanted to talk about primarily here were the actuator, or the prototype, and I'm thinking actuator based, or is it a higher priority to resolve now whether we want to use the window motors? Which means I get a hold of Dave, ask him to recommend a couple, ask him to give me some insight into how to mechanically attach it, and then we'll figure out the electronics, and we'll figure out if that makes sense for us.
I think it makes more sense to take that second approach, because then you're not doing everything twice.
Well, true. If we are gonna do the window motors, now's the time to learn about it.
Yeah.
Instead of using the actuators and saying, geez, now we really prefer the window motors. We do enough stuff. If you got curtains for this thing, you're gonna want to do that with window motors.
Yeah.
So the more we learn about this, even if we choose to learn that window motors aren't what we want to use in the neck, we still won't waste the window motors.
Sure.
They'll still be for your curtains, and you use a rocker switch.
Yeah.
Turn them on and off.
Yeah, I say we get some.
Okay. So then,
How are they configured? I mean, how
it's a 12-volt battery going to run it, so no problem with power. Current power supply will still handle it. Okay. We're in good shape there. The issue gets to be, how do you send the signal? It's going to be a pulse width modulation signal. We're going to do that with a Sabertooth. Okay. That didn't change.
Right.
So it's all about the feedback. When we first power this thing up, where are you?
Well, we just gotta mount a pot somewhere with, a gear on it that has some kind of, teeth that it goes into. People have done that on the cross sim,
Okay.
I remember reading about people doing that, because a lot of people use like windshield wiper motors for those single person motion simulators. And I remember there was a thread about getting motion feedback, because obviously a windshield wiper motor doesn't have feedback built in either.
Right.
And it was, you chassis mount a pot, maybe multi-turn depending on how much it's going to turn,
Right. What the limit of the motion is, yep.
Yeah.
Or how big your gear is, or whatever.
Set of teeth that would go into the gear.
Yep. Okay.
It shouldn't be too bad.
That's an excellent point. And then the pot is read by the helper tooth. We're already doing that with the other thing.
Exactly.
And if it isn't 10K, it doesn't matter. We can program the helper tooth to whatever, whatever's appropriate for us.
Yeah.
So then that should save us a lot of money. Then it's just a matter of how do you mechanically link it.
Mm-hmm.
So, it's not just, a pulling.
Oh, yeah.
Because, you've also got to be able to go the other way and push. So.
Yeah, I mean, I replaced my mother-in-law's power window motor in her Windstar.
Okay.
And that one was kind of like an X.
Scissor?
Yeah, scissor. Yeah. So it would kind of do that sort of thing.
Yeah.
But it was interesting because there were like 2 attachment points on the bottom, 2 on the window, which kind of makes sense.
Yep.
But it almost looked like, depending on your configuration, maybe you could have had something with just one. I don't know if we would have to connect it with a spring or something like that, or connect 3 of the points to something fixed. I don't know if that would work or not. It might not work, but there's certainly some things to try, and I'm sure it also depends on the design of the window regulator too.
Right.
Right. But part of that also is that it's expecting to push up and down something that's on tracks.
Right.
So so there's some amount of, it's expecting the load to be,
Guided.
Yeah.
Okay.
So it's not just gonna, you want it to push anything, pull anything. It's not just gonna work. You got to kind of think about how you're gonna use it. But but it sounds like Dave's already done that kind of thing at Autocrafting. So it sounds like he would definitely be able to use his expertise.
Right. Okay.
And I'm also sure, from what he was saying, and also just from experience with electrical systems on cars, everybody does it a little differently. So
Sure.
you know,
There's a lot of configuration, so I
Yeah.
can learn from them
Yep.
and see what might be right for us.
There's even aftermarket stuff. I don't know if that would be helpful or not. It sounds like what we want is really the full regulator. And the regulator I got was it was like $60 on eBay, or no, Amazon. It was Amazon.
Okay.
But I'm sure, if we know what we're looking for, we can
Sure.
find,
Okay.
or go out to the good old pick and pull in Brockport and grab one out of a car.
We could do that. I'm hesitant to do that because in the end, we want them all to be the same.
That'd be good for.
And we know the history of it and
Oh, yeah.
whatever.
But that'd be good for maybe prototyping. We could probably do that real cheap,
Yeah.
versus buying a new one. And, I mean, once we know this is what the configuration's going to be, then we start over with a new one. Now we know how to design the mechanical linkages and everything.
Right.
And obviously we never put a used one into one of the actual animatronic figures.
Right.
But just for experimentation, it might be worthwhile. We find a nice common vehicle that has working power windows. We obviously don't want to pull a broken one.
Right. Exactly. Okay. So, are we in agreement that the next phase, my next assignment, is really to focus on power window understanding, and then after that, install that in some sort of a prototype neck?
That's what I think.
Okay.
I think software-wise, you're leading the pack right now.
Right.
I mean, you're just a few steps away, or maybe even one step away from the animator being able to really start to play with it.
Well, I'm about 8 hours away from full record and playback with pause, continue, etc.
Yeah, so you're way
So,
ahead of the curve.
I'm not
you're
worried
probably
about that.
a year ahead of the curve.
Okay.
So
But part of this is needed for the MFP. Okay.
I think that the next step is to take us past where we are mechanically.
Right.
And you're right, we're hitting that threshold. And this is where John's comfortable, so maybe he does the birds.
Well, and that's where I'm in. And I believe that John is going to bring a lot to bear. More mechanic ideas. Mechanical linkage, alignment, structural frame, all of that kind of stuff. When he sees this working.
Yeah.
Okay. So in the meantime, if we knew what kind of birds and what sizes, he could get started on one of those. So we're not losing time. He's not losing time.